want to do anything of significance, you're going to have to be able to figure out how to get there. So the idea behind the Smart Steps document we wrote was how you would do teleoperation systems on Earth up to various pieces, all located in an underground facility on the moon. Because why would you go and try and sit in a radiation environment, at a micrometeor environment, where you blow yourself up, when you could be 20 feet underground again and put a door on it and get oxygen and all the great things to build labs and build telescopes and all the things you want to do. And so that's what we proposed. And everybody kind of thought that was a cool idea. Because, you know, we went down to the AIAA conference and everybody went, wow, that's neat. We hadn't really thought about it until you go and you pull out the document from the US military. First thought about doing it in 1959, and it was an underground mine. And we've gone through this whole phase, 50 years, 52 years, where everybody goes, no, we'll just go up there for the camping mission, and we'll get our pup tents and set them up, and we'll do whatever we have to do. But when you're going to get serious about it, you got to do serious things. And one of them is to look at how you would go underground. So we decided we would start, and the other guys that are here at the competition, we were in the competition with our research team in 2009 at NASA, the Lunar Regolith Digging Competition. This is the little robot that we made, and the reason we went in it was because that was the first time that NASA decided that teleoperation might be a viable option. And teleoperation was what our research was about. And so we did teleoperation work, and we created a teleoperation system to run a robot on the moon. And it was good. We weren't that great of mechanical engineers, so we didn't get the 500 kilos in the thing. These guys managed to do that because they're way better mechanical engineers. But we did the teleoperation part, and we were very proud of it, and the NASA people were quite interested in it. And I'm really glad they won the competition, because now you see the kind of people we have that are starting to come into Laurentian. They're very, very good and talented. Then the people at that analog site, they wanted me to go down and be in mission control for a geologic mission to Mars. So I spent last summer about a month in the NASA Desert Rats program. What was fascinating about the NASA Desert Rats program for me was they were going to study at the Black Point lava flow just out of Flagstaff, Arizona, this. They said it's very an analog to what would happen in lunar surface volcanism. They put 4 astronauts in 2 of these. You don't want to know what I told them about those, because that wasn't pleasant. But it worked for what they had to do. It probably isn't what you want to do if you want to go explore on Mars or the moon, but it worked. In the back of this are a bunch of geologic tools. I hold a prospector's license, and being a prospector, you have a hammer, you have a knife, and you scratch things, and you have a couple other basic tools. So they created this huge device to do all this, and then they provided them with a hammer and with a scraping tool, a little knife, and all those things, and baggies that had precise numbers on of exactly where they got the samples. And the part that I loved was I sat there at night with the 4 other people who ran mission control all through the Apollo missions. And those guys, the wealth of experience sitting in that room was amazing. And getting to hear the stories about how they got people back and what they did, and that was the value for me in going. They did this in a way that they were very successful. There's a published paper coming out in the next, I think, month or 2 about what we did, but it was perfect. And now what happened was, as a result of doing all that work, I got asked to go and speak at NASA Ames. And it was for the Space Manufacturing Conference in 2014. And it was really neat. Craig J. Venter was one of the guys at the conference as a keynote speaker with me, and I thought, wow, that's a different world. He's really good at what he does. I just do what I do. But I ended up meeting a bunch of people, and they decided that they wanted me on the team to be able to work with them. And so we've been talking over the last few days, and I said, you know, I really want to show everybody an idea of what is really innovative and where this might go. because we're working on this team together to solve this problem. Shackleton Energy has the idea to put water in low Earth orbit. They have a plan. They're out raising money. The amount of money they're getting is quite significant, and I'm on the team helping them build the robots to go to the moon. This video just shows an idea of what it is that they're doing, and it'll let you see what we're going to be working on over the next probably 10 years. What's important about that video is not so much that it's all glamour, it's that it's going to be the first mine off of the planet. And I'm very keen to be involved in the first ofs in underwater mining and the first ofs of whatever we do being off the planet. We get the good fortune of, in our business and in my research, to be the ones working on the lunar outpost for mining. Part of it's because we've been in the competitions at NASA and people have seen what we do, and part of it's because we're coming at it from an area of being in terrestrial mining robotics, and we understand how to do the mining. And so we're very keen on moving forward in this and a number of other initiatives, but it takes all this research that we've done over the past 25 years and puts it into a perspective of working on some of the biggest things that have to happen for our planet. And so with that, I'll leave you here so that if you have any questions or anything, I'll try and answer them. Thanks.